Today, we're going to look at how you solve a quadratic by factoring. There'll be several methods we use to solve quadratics, and the first one typically you look for is factoring, because it's usually the quickest way to get the answer. When we solve a quadratic, we're usually looking for a case where y is 0. Remember that if you graph a quadratic and y is 0, those are the x-intercepts. We also call those zeros. But we turn this into the equation 0 equals x squared plus 5x plus 6. Then we factor the polynomial as a standard form. We're looking for two things that FOIL to x squared plus 5x plus 6. We know when we FOIL that x times x makes x squared. We know that this number times this number makes positive 6. So the signs could either be two negatives or two positives to make positive 6. Since the middle is a plus, it's got to be the two positives. Now we're looking for two numbers that multiply to 6, but when you add them, they add to 5. That would be 2 and 3. Remember, you can FOIL by checking your answer. Notice that x times x is x squared. Positive 2 times positive 3 is positive 6. And then the 5x comes from the inside and the outside, multiplied and then added together. 2 times x is 2x, 3 times x is 3x, and 2x and 3x make that 5x in the middle. When we find the solution to this, the idea that if two numbers, say a and b, multiply to 0, then the solutions come from when a is 0, because if a was 0, 0 times b would be 0. And the other solution would come from when b is 0, because whatever a is, if b is 0, it's 0 times a, which is 0. What you do then is you ask yourself, what do you plug in for x that makes x plus 2 0? You're really solving this equation. What makes x plus 2 equal to 0? Well, if you subtract 2 from both sides, you see that x would be negative 2. If you plug in negative 2 for x, negative 2 plus 2 is 0, and 0 times anything is going to be equal to 0. A quadratic will often have two answers. There's another factor here, and there's a value that makes it 0. What makes x plus 3 equal to 0? If you subtract 3 from each side, you see that x would be negative 3. And if I plugged in negative 3, negative 3 plus 3 would be 0, and 0 times this would be equal to 0. So the solutions to this quadratic are negative 2 and negative 3. They are also, if you graph y equal x squared plus 5x plus 6, they are the x-intercepts, or the zeros of that equation, and they are the solutions to the equation x squared plus 5x plus 6 equals 0. Look at the graph of y equal x squared plus 5x plus 6. Do you see how the parabola intersects the x-axis at negative 3 and negative 2? Those are our solutions. Also notice that the y-intercept is 6 and that it's sitting right there, because when you put in x is 0, 0 squared plus 5 times 0 plus 6, y ends up being 6. 0, 6 is the y-intercept. On your next assignment, the main focus is to find solutions to a quadratic equation. To do that, we need to get it equal to 0, factor it, and then find the values you plug in that create 0, because 0 times anything is 0. A few examples before we get going on the questions from the assignment. A reminder that there's several kinds of factoring. The The first thing you're supposed to always look for is the greatest common factor. 2x squared minus 4x both have a common factor of 2x. So I'm going to factor that out. I'm thinking distributive property. 2x times x is 2x squared minus 2x times 2 is 4x. Now I'm searching for values to plug into each factor that create 0, because 0 times anything is 0. Out front here, this is 2 times x. Keep in mind that you're multiplying out front, and the only solution there would be x equals 0, because 0 times 2 would be 0, and 0 times whatever x minus 2 is will also be 0. For the second factor, x minus 2, what makes that factor 0 is x equal 2, because 2 minus 2 is 0, and 0 times anything will be 0. Keep in mind that when you find this answer, you're really solving the equation, what makes x minus 2 equal to 0? Add 2 to both sides, and I can see that x would be equal to 2. If you were asked to solve the equation in red here, you'd have to remember what I said on the previous pages. You need it equal to 0. Solving a quadratic uses that idea that two things multiply to 0, each factor's got to be equal to 0. So the first step would be to move the 16 over and subtract 16 from both sides. Minus 16 minus 16. This would become x squared minus 6x minus 16 equals 0. Now I can solve it and factor it. X times x makes x squared. This number times this number makes negative 16. It's got to be a positive and a negative. I need two numbers that multiply to 16, and they subtract to 6, which would be 8 and 2. But really, when I place them, they've got to add to negative 6. So make 8 and 2 add to negative 6. That'd be negative 8 and positive 2. To find the solutions, I'm asking myself, what do I plug in that makes 0? You're solving this equation. X plus 2 equals 0. Subtract 2 from both sides, and x would be equal negative 2. Putting in x equal negative 2 makes this factor 0, and 0 times anything is 0. The other one, from this factor, I would solve the equation x minus 8 equals 0. I'd add 8 to both sides, and x would be equal to 8. If I plug in x equal 8 in this factor, 8 minus 8 is 0, and 0 times anything will be 0. Now I want to look at one last example before we go to your problems from the assignment, because we haven't seen this yet. Here we're solving a quadratic, and to factor this, we have to realize that number in front changes everything. This is the case where I multiply 3 and 8. 8 times 3 is 24. I find two numbers that multiply to 24, positive, but they add to the middle term of 14. That would be 2 and 12. 2 times 12 is positive 24. 2 plus 12 is 14. I use this information to rewrite the middle term. 8x squared plus 2x plus 12x plus 3 equals 0. Now we can factor by grouping. These first two have a 2x in them. 2x times 4x plus 1. The last two have a 3 in them. 3 times 4x plus 1. Both terms, separated by this addition, have 4x plus 1 in them. I'm going to pull it out front. It's a greatest common factor. 4x plus 1 times 2x plus 3. Now, you've noticed that I have showed an equation when I've been solving these. And the reason I showed that equation is to emphasize, if you have a hard time seeing the answer, make the equation and solve. The problem here is that the solution to both of these are going to be fractions. So what I do is I set it equal to 0. When is 4x plus 1, 0? I take a 1 off each side. 4x would equal negative 1, and I divide by 4, and I get one answer of x equals negative 1/4. I can prove to you that this works if I plug in negative 1/4. So imagine getting rid of the x, replacing x with negative 1/4. Notice how the 4's would cancel, and negative 1 plus 1 would be 0, and 0 times anything would be 0. My second answer comes from when 2x plus 3 would be equal to 0. We'll take a 3 off each side. 2x would equal negative 3, and divide by 2. And my second answer is negative 3/2. I can prove that that works. If I take the x away and I replace it with negative 3/2, the 2's cancel, and negative 3 plus 3 is 0, and 0 times anything is 0. The two solutions to this quadratic then are x equal negative 1/4 and x equals negative 3/2. Both of those are solutions. The rest of this video is questions from your assignment. Here we have a factored quadratic. So they've done the work for us. We're just trying to figure out the value that you plug in that creates 0. If I can make this factor 0, 0 times anything will be 0. You're solving the equation. Z plus 4 equals 0. And the other answer will come from z plus 8 equals 0. Well, here I can see it would have to be negative 4 if I subtracted 4 from each side. And here it would be negative 8 if I subtracted 8 from each side. Plugging in either negative 4 or negative 8 would create 0, such that 0 times anything equals 0. Just like the last one, but both signs are negative. I'm trying to find out what makes z minus 2 0 and what makes z minus 7 0. If I add 2 to both sides, z would be equal to 2. 2 minus 2 is 0, and 0 times anything is 0. For the second one, if I add 7 to both sides, z would equal to 7. And if I plug in 7 in the second factor, 7 minus 7 is 0, and 0 times anything is 0. For question 3, notice the number in front. This factor is going to have a fractional answer. If you're not sure what it is, just set it equal to 0. Find out what value of x makes that 0. Add 1 to both sides. 4x will equal 1. Divide both sides by 4. And x equal 1/4 is one of the solutions. The other solution right here would be 2. If I plug in x equal 2, 2 minus 2 is 0, and 0 times anything is 0. In question 4, we have a couple more fractions. So let's just set each factor equal to 0. We'll subtract 3 from each side and get 4x equals negative 3. And divide by 4, and there's our answer, negative 3/4. For the other one, we'll add 1 to both sides and divide by 3, and our other answer is x equals 1/3. In question 6, we need to factor. X times x is x squared. This number times this number makes negative 36. It's positive and negative. Factors of 36 is subtract to 5. Are 4 and 9? Now when I place the 4 and the 9, I have to make them add to negative 5. That would be negative 9 and positive 4. Now I'm trying to find the values I plug in that create 0. Looks like negative 4 plus 4 is 0, so x equals negative 4. And here it looks like 9 minus 9 is 0, x equals 9. And those are our two solutions. In question 7, we need to factor again. X times x is x squared. This number times this number makes negative 28. Got to be a positive and a negative. Factors of 28, this subtract to 3 are 4 and 7. But I've got to make them add when I FOIL to positive 3. Make 4 and 7 add to positive 3. That'd be positive 7 and negative 4. Now I need to find the values I plug in each factor that creates 0. Looks like negative 7 because negative 7 plus 7 is 0. 0 times anything is 0. And x equals 4 because 4 minus 4 is 0. And 0 times anything will be equal to 0. Question 8. Let's factor that. Standard form polynomial. Quadratic. This number times this number makes positive 110. So it's either got to be a positive times a positive or a negative times a negative. The middle is a negative, so that means my two signs are negatives. I need two numbers that multiply to 110 but add to 21. I think it's 11 times 10. Yeah. Signs are the same. I can put them wherever I want. What do you plug in that creates 0? That would be 11. 11 minus 11 is 0. And here, 10. 10 minus 10 is 0. Question 10 is not a standard form. The first thing you should look for factoring is the greatest common factor. This turns out to be x times x minus 5. Greatest common factor is x. I have two factors with an x in them. As long as I have two factors with an x, then I'll have two solutions. What creates 0 right here? That would be x equals 0. 0 times x minus 5 would be 0. The other one would be x equals 5, because 5 minus 5 is 0, and 0 times x would be 0. Question 12. X squared minus 9 equals 0. There's more than one way to solve this. There's more than one way to solve all of these. But in particular, factoring, this is a difference of squares. It's something times something. We have subtraction, and we both have squares. And remember how that's x plus and x minus to make negative 9, and 3 and 3. The reason this works, as a reminder, x times x, yes, is x squared. Positive 3 times negative 3 is negative 9. The inside and the outside, when you add them together, create 0. On the inside, I get 3x positive. On the outside, it's negative 3 times x, negative 3x. And those two together make 0, which is why I only have two terms here. The solutions you can see, though, what do you plug in that creates 0? That would be negative 3. And here, if you plugged in 3, you would get 0. Those are my solutions, 3 and negative 3. In question 14, the problem is it's not equal to 0. We use the idea that if two numbers multiply to 0, then the solutions come from when each factor is 0. I need to move the 8x over here, subtract it from both sides. That'll be x squared minus 8x. And I need to move the 12 over here. It's a minus 12, so I'd have to add 12 to both sides. making this a plus 12. Reminder, when you move terms to the other side of the equals, the sign changes because you do the opposite to move it. Use the inverse operation. X times x is x squared. This number times this number is positive 12. It's either two negatives or two positives. We have a minus, so it's two negatives. Factors of 12 to add to 8 are 2 and 6. Negative 2 times negative 6 is positive 12. And negative 2x and negative 6x make negative 8x. The solutions come from when we get 0. 2 minus 2 is 0, so x equals 2. And x equals 6. 6 minus 6 is 0. Question 15 is again not equal to 0. I'm going to move the 63 over here. I'm going to subtract it from both sides. 0 equals x squared minus 2x minus 63. Let's factor this. X times x is x squared. This number times this number makes negative 63. It's got to be a positive and a negative. Factors of 63 that subtract to 2 are 9 and 7. Now when I place 9 and 7, I have to make them add to negative 2. That'd be negative 9 and positive 7. The solutions come from what values create 0. That'd be negative 7, because that plus 7 is 0. And 9, because 9 minus 9 is 0. Question 17 is also not in the right form. I need to have it equal to 0. Let's take a 6 off each side. 0 equals 5x squared minus 13x minus 6. There's a number in front, so I'm going to multiply those two. 5 times negative 6 is negative 30. I need two numbers that multiply to negative 30, but when you add them, they make the middle term of negative 13. That would be negative 15 and positive 2. Negative 15 times 2 is negative 30. Negative 15 plus 2 is negative 13. I'll use that information to rewrite the middle term and then use factoring by grouping. The first two have a 5x in them, and that's x minus 3. The last two have a 2 in them. Positive 2 times x is 2x, and positive 2 times negative 3 is negative 6. Now I have two terms separated by this addition. Both have x minus 3 in them. This becomes 0 equals x minus 3 times 5x plus 2. The one solution we can see at a glance, because 3 minus 3 is 0, x equals 3. The other, let's set it equal to 0 and solve. 5x plus 2 equals 0. Subtract 2 from both sides. 5x equals negative 2. Divide by 5. And our second solution is x equals negative 2/5. This example is just like the last one. We need to get it equal to 0. Let's move the x over. We're going to subtract it from both sides. It'll be 2x squared minus x. And we need to move the 15 over. We'll subtract it from both sides. I'll have a minus 15 on the other side, and this will be equal to 0. This is the harder type of standard form. I'm going to take 2 times negative 15. That's negative 30. I need two numbers that multiply to negative 30. But when I add them, they make a middle term of negative 1. That's my middle. That'd be 5 and 6. So 5 times negative 6 is negative 30, and 5 plus negative 6 is negative 1. Let's rewrite the middle term. 2x squared plus 5x minus 6x minus 15. First two have an x in them, x times 2x plus 5. The last two have a 3 in them. Be aware that this is negative 3 times something makes negative 6. That'd be 2x. And negative 3 times something makes negative 15. That's positive 5. Both terms are separated by this minus, and they both have 2x plus 5 in them. That's 2x plus 5 times, my other factor is going to be x minus 3. Just like the last example, one factor, we can see the answer at a glance, x equals 3, because 3 minus 3 is 0. The other one, let's make an equation. 2x plus 5 equals 0. Subtract 5 from both sides. 2x equals negative 5. And divide by 2. And there's our second answer, negative 5/2. Question 19 looks kind of terrible, but it turns out it's not. The issue here is those numbers are kind of large, but remember that the first thing you want to look for is a greatest common factor. And it turns out the 7 goes into 119 and 49. So there's a greatest common factor of 7 in everything. I get x squared plus 17x plus 70. We now have a 1 in front of this x squared, making it an easier standard form. All I need are factors of 70 that add to 17, and that's 10 and 7. So it looks like our signs are plus and plus, and 10 and 7. And yes, that 7 would come down, but you're not going to get an answer from that 7 because there's no x by it. There's nothing to plug in. In fact, if you wanted, because there's no x, you can't do that if there's an x there, because then there'd be a solution. There'd be a factor that you could plug something into. But you could divide both sides by 7. 0 divided by 7 is 0. And this would just become x plus 10 times x plus 7. So that 7 doesn't really matter because there's no x next to it. The two solutions are negative 10 because negative 10 plus 10 is 0, and negative 7 because negative 7 plus 7 is 0. Here's a case where you're actually solving a cubic. Question 20 is a cubic. That's power of 3. Notice the greatest common factor of x times x squared plus 8x plus 12. This is x times, this is the easy kind of standard form. Looks like plus and plus. Factors of 12 to add to 8 are 6 and 2. There are actually 3 answers to this question because there are 1, 2, 3 factors with x in them. Here, x equals 0 is a solution because 0 times all that other stuff would be equal to 0. Here we get x equals 6, actually negative 6. Negative 6 plus 6 is 0. And this last one would be negative 2 because negative 2 plus 2 is 0. I have 3 answers. You're going to list them with a comma between them. 0, negative 6, and negative 2. In question 21, first we're going to find the value of x of the vertex. Remember that x equal the opposite of b over 2a is the equation of the axis of symmetry. It's also the x-coordinate of the vertex, because the axis of symmetry passes right through the vertex. The opposite of b, here's my a, it's 1. Here's my b, it's -2. And there's also a c. Notice it's 0, because there's nothing there. We don't need c right now, but keep in mind that c would be 0. The opposite of b would be 2. The opposite of -2 over 2 times 1. This would be 1, so x equals 1. Now we want to find the vertex, so we're going to plug that 1 in the equation. Y equals 1 squared minus 2 times 1. I'm putting 1 in for x. 1 squared is 1, so this is 1 minus 2, which is -1. So the coordinates of the vertex are 1, -1. On the second part, you're going to graph this thing. You're going to click on the vertex, but you need one more point. The easiest point to get is the y-intercept. Remember, if you take this equation, y equals x squared minus 2x, I'll point out that it's plus 0, and I plug in x equals 0. Notice that it's 0 squared, 2 times 0, and 0. Y ends up being 0. So for your 2 points, first click on 1, -1, then click on 0, 0, and graph it. The next thing we're going to do is factor it. This has a greatest common factor of x, so it's x times x minus 2. Then we're going to solve the equation. 0 equals x times x minus 2. This will give us the x-intercepts. When y is 0, you're on the x-axis and you get the x-intercepts. If I plug in x is 0, that'll be a solution because 0 times x minus 2 will be 0. One solution is 0, and the other will be x equal 2 because 2 minus 2 is 0. And this was x times x minus 2. The ordered pairs are, remember y is 0 when we're looking for the intercepts, the x-intercepts. The ordered pairs then are 0, and y is 0, and 2, and y is 0. Notice anything? We've got to look at the graph. Look at the graph and look at these intercepts we got by solving this equation. Notice our intercepts are 0, 0, and 2, 0. And if you look at the graph, we can see that it hits at the origin, that's 0, 0, and on the x-axis at 2, 0. We can see the vertex that was 1, -1, and we're down there at the bottom. Also note that the axis of symmetry is the vertical line x equal 1. It always goes through the vertex and has the same x as the vertex. One last example. Our a is 1 in front of the square, b is 4 in front of the x, and c is 3. C is the y-intercept, because if I put in x is 0, those two drop out, and I get y equal 3. 0, 3 is the y-intercept. Let's calculate the vertex. The opposite of b is -4 over 2 times a, 2 times 1. That's -4 over 2, which is -2. Take that -2 and plug it in the equation. Y equal -2. Notice the parentheses. You must have parentheses. Squared plus 4 times -2 plus 3. This is 4 plus -8 plus 3. 4 plus -8 is -4, and -4 plus 3 is -1. The vertex then is -2, -1. Choose a second point. A good point would be the intercept of 3, 0, 3. So choose the vertex and then choose 0, 3 and graph it. In factored form, we need factors of 3 to add to 4. There are 3 and 1. So this ends up being x plus 3 times x plus 1. What are the solutions when y is 0? They are -3 because -3 plus 3 is 0, and -1 because -1 plus 1 is 0. Y is 0, so the ordered pairs would be -3, 0, and -1, 0. Do we notice anything? Well, look at the graph. See how the vertex is -2, -1. How the x-intercepts are -3 and -1. And how the y-intercept was 0, 3. We can get all those points quickly, especially when a quadratic factors.